Okay, 62. We have three identical charges, and they're all positive. So look, positive charge, positive charge, positive charge. The masses are all, so they're identical. The mass of each sphere is 0.1 kilograms, and they hang from three strings as shown. Okay, the length of the left and the right strings are each 30 centimeters, so that's 0.3 meters. And these angles here are 45 degrees. 45 degrees, 45 degrees. So before we do anything, we got to figure out some distances. So for example, let's figure out what this distance is right in here. Okay? How do we find out that distance? Well, we got a triangle. Look at, we got this triangle right here. So just apply trig to that triangle, that distance right there. So let's call that, I don't know, R1. That distance in there is R1. That's going to be sine 45 times 0.3 meters. And so R1 is, that comes out as 0.2121. 0.2121 meter. So then what would this distance be from here all the way over to there? Let's call that distance R2. That's just going to be double. You just double it, double R1. So that comes out as 0.42426, 0.42426 meters. Okay, we're trying to find what the charge is, and all three charges have the same value. So we're looking for what these Q's are. Okay, the way you're going to do this, and this would be too lengthy for a multiple choice question. Multiple choice questions tend to be quicker. This would be a free response question, like on the midterm. I'd give you something like this on the midterm exam. All right, so we're looking for Q. The key to the problem lies in free body diagram, sum forces, and then work the algebra. Now I solved it by focusing on this guy right here. Could you have focused on this guy? Yeah, you could solve it by focusing on either of those guys. Could you have solved it by focusing on the middle guy? I don't think so, because that doesn't incorporate, the middle guy doesn't incorporate the 45 degrees. You got to get that 45 degree into the problem. I think I'm just kind of talking off the top of my head. So my solution here, I focused on this guy here on the right. So how many forces act on this guy? So here he is right here. I'm doing a free body diagram for this guy on the right. What are the forces acting on this guy? Well, we have tension up like this. We have mg down like that. And then we have two forces to the right. Now, what are these two forces? Well, look, let's give these guys numbers. Let's call this guy charge 1, this guy will be charge 2, this guy will be charge 3. What is charge number 2 doing to charge 1? Attracting or repelling? Repelling. So now what's the equation for force between charges? The equation for force between charges, KQQ over R squared. So this first force, I would just go KQ squared, right? Because what's Q times Q? Q squared, and the Q's are all the same. The charges are the same. So KQ squared. Now what's the distance between 1 and 2? What's this distance in between here? That's 0.2121. So I just plug, let's just call, what I call that R1. R1 squared, right? The R1 is the 0.2121. Okay, the other force, now what's charge 3 doing to charge 1? Repelling it also. So that's going to be KQ squared over R2 squared, where R2 is double R1, right? R2 is the full distance from there to there. This is what R2 is. Okay, and then this angle right here is 45 degrees. Okay, so if you don't have the correct free body diagram, you're not going to get this problem right. You have to have the correct free body diagram. So any questions on the free body diagram? Okay, so I'm going to erase this now because we're going to sum forces. So the next thing we do, we sum forces X, we sum forces Y. So in the X direction, we have three forces. we have KQ squared over R1 squared plus KQ squared over R2 squared minus cosine 45t. Sum of the forces equals ma, but what's A? 0. So boom, we have an x equation. Now, the y equation, we have two forces in the y. We have the y component of tension and then mg. So this is going to be sine 45t minus mg. Sum of the forces equals ma, but the a is 0. It's not accelerating. So bam, like that. Now, you can take this equation. I'm a little short on time here, so I'm going to leave out the algebra. M is 0.1, okay? G is 9.8. So when you do the algebra, you get T equals, if you do it correctly, you should get 1.38593 newtons. Then you take that, plug it in up there. Now look, the only thing missing in this equation, what's the only thing we don't have in this equation? Q. So you just got to do algebra. So let's see, the bell's going to ring in 2 minutes. So you do the algebra. Look, what's R1? Just to make sure everybody's got this. R1 is 0.2121. What's R2? 0.4242. What's K? 9 times 10 to the 9th. You plug everything in. You solve for Q, and it basically rounds to 2 times 10 to the negative 6. So what does the book call that? What is 10 to the negative 6? Not nano. Micro. That's 2 microcoulombs. So, A, too lengthy for a multiple choice, right? But that could definitely be free response. Definitely.